Good morning, this is your Stats Sensei, Mr. Spensei, and this is an assignment on the Z interval. In other words, we're going to be running a confidence interval. Our scenario is bread na for sodium. A company that produces white bread is concerned about the amount of sodium in its bread. The company takes a simple random sample of 40 slices. Hey, that's nice to know that it's simple random. We have a sample size of 40. All right. It computes the sample mean to be 103. So there's our X bar, sample mean of 103. Assume that the amount of sodium per slice is normally distributed. All right, that's important to know. But even if it weren't, we would be, because we have a sample size that's large enough, it would be fine. So construct a 98% confidence interval for the unknown mean sodium level, assuming that the population standard deviation is 10. All right, so we have a population standard deviation of 10, and we have a confidence level of 98%. So let's go ahead and start filling out our template. So our formula is going to be X bar plus or minus Z star, standard deviation of the population divided by the square root of n. Well, they told us that X bar, our sample mean, was 103. They told us we had a sample size of 40. And they also told us the standard deviation, well, they told us the standard deviation of our population was 10. And our confidence level that we want is 98%. All right, so I need to calculate Z star. Well, Z star means I'm going to have to go to an inverse norm. And it's going to ask me for my area, which in this case is 98 divided by 100, is 0.98. And since it's a Z, all Z's have a mean of 0 and a standard deviation of 1. And we want second vars, inverse norm. And in this case, we want centered. All right. So 0.9801. And we end up getting two numbers. And all we care about is making it positive, which happens to be 2.3263. All right. So there we go. That's our Z star. And we're going to draw what this looks like. Well, all confidence intervals are centered on the sample mean, which means they're centered on X bar. And our X bar in this case was 103. And we know that this area in between here is 0.98. All right. So that's what our picture looks like. And we're going to be looking for a lower bound and an upper bound is what we're going to be looking for. So we're going to plug this into our formula, all of our information. So our sample mean it becomes 103 plus or minus our Z star, which is 2.3263 times the standard deviation, which is 10, divided by the square root of 40. Now, in this case, how many samples did we take? Because ultimately, at some point, we're going to be taking multiple samples. So in this case, we have one sample. So we need to say that one sample. And we're going to be using the Z interval, and we're interested about the population means. And we're just going to write means. So one sample Z interval for means. Well, now that I have that information, I can go ahead and run this test. So I'm going to go to stat test, drop down to Z interval, which happens to be number 7 on my calculator. I'm going to highlight the word stats, and it asks for my standard deviation. Well, my standard deviation we recorded as 10. We recorded the sample mean of 103. a sample size of 40, and we want a confidence level of 0.98. All right, or 98 divided by 100. So there's my lower bound and my upper bound, and I just need to write that down at this point. 99.322 and an upper bound of 106.68. So this is lower, this is upper. All right, our parameter. We always have to define what we were interested in. In this case, construct a 98% confidence interval for the unknown mean sodium level. All right, so let mu, that's the population mean, equal the true population mean. And by the way, this phrase right here, we're going to be using over and over and over again. So get used to it. Let mu equal the true population mean amount of sodium in the bread. That's what we care about. All right, so next thing, conditions, random sample. Well, when I look up here, they said, oh, random sample of 40. That's good. So I'm going to write that down. That's the first condition. Was random sample made? Well, it was. We have a random sample of 40, and that was given. The next one, the N is less than 10%. Well, in this case, we need to check our sample size. All right. And our sample size is 40. So we're going to have to go 40 times 10 equals 400. They didn't tell us our population size, so we don't have a population size to compare to. Now, that's interesting. My question to you is, do you think that they produce more than 400 slices of bread? And the answer is, yeah, they probably do. So we have this sentence that we have to write. Reasonable to assume that there are more than 400 slices of bread. The sample size is less than 10% of the population. Now, I got to be honest with you. Most of the time, we're going to give you the population size and you'll just make a comparison. And as long as it's less than 10%, we're good to go. All right. So, number 3, normality, which I think is the most important condition. In this case, they told us it was normal, but they also told us we had a sample size of 40. So I want to talk about the sample size. Since they told us it was normal, we could have written normal given, but let's act like they hadn't and they just said, hey, we have 40 slices of bread. Well, n equals 40, which is greater than equal to 30. The distribution is approximately normal, and I'm going to abbreviate approx, normal by central limit theorem. Now, ultimately, we're just going to call that CLT. Makes it a lot easier, CLT. So then we have our conclusion. In our conclusion, we are 98% confident that, what are we 98% confident about? the true population mean amount of sodium of sodium in the bread lies within the interval. And then we just need to list our interval. In this case, our interval is 99.322, comma, 106.68. All right. The next thing, we have to explain what it means by 98%. Well, 98% means, hey, if we did this over and over again, we expect that this method will work 98% of the time. So in this case, we're going to say in repeated sampling, we expect this method or our method to capture what? The true population mean amount of sodium in the bread how often? 98% of the time. So, in repeated sampling, we expect this method to capture the true population mean amount of sodium in the bread 98% of the time. And that's our confidence interval. And that's basically all the steps. I sure appreciate you watching. Look forward to seeing you on the next one. Thank you.